Hi and welcome to this video on differentiation, and in particular implicit differentiation. Now, what do we mean by implicit differentiation? Here it's when the equation is given to you and it's not explicit. So by that we mean that the equations usually are given to you as y equals a function. So in these cases where the equation is implicit, the x and the y are mixed up together, so they're not of this form, and they can be either on one side or both sides of the equal sign. It may be difficult to get x or y on one side, and in these cases we use implicit differentiation, and how we do this is we differentiate both sides with respect to x. So differentiate both sides with respect to x, and we can abbreviate this as with respect to x. Now, using the chain rule, dy over dx is dy by du times du by dx. We can think of the du's as cancelling each other out, and we're left with dy by dx. Similarly, if we use a different variable, so we use z and y, then this rule applies. Dz by dx equals dz by dy times dy by dx. So the dy's cancel out and we're left with dz over dx. Now suppose that z equals y squared. It follows that dz over dy equals 2y. So in this case, if we have a little aside, y squared equals d by dy y squared dy by dx. So this in essence is the rule of implicit differentiation, and using the chain rule, dz by dx equals dz dy times dy over dx, and that equals 2y dy dx. So here we have the rule for implicit differentiation written out. To differentiate y squared with respect to x, we differentiate y squared with respect to y, and then we multiply by dy by dx. Let's have a look at this in action. So if we have the equation for a circle, which is y squared plus x squared equals 16, and we want to differentiate that using implicit differentiation. So we differentiate both sides with respect to x, d by dx y squared plus d. So here we're differentiating both sides with respect to x. When we differentiate the y squared with respect to x, we get 2y dy by dx, which we can write as that notation. When we differentiate the x squared, we get 2x, and when we differentiate the 16, we get 0. So y prime becomes minus 2x over 2y, which is minus x over y. And that is your answer. Now you may say that we don't need implicit differentiation for that previous equation we had for a circle, which was y squared plus x squared equals 16. We can just use the normal rules of differentiation. So let's try and do that. So y squared plus x squared equals 16. Get y squared onto one side into something that we recognize, which is 16 minus x squared. So y equals, when we have a square root of 16 minus x squared, we have to put the plus and minus notation. If we write this in a form that we can differentiate, so we have plus or minus brackets 16 minus x squared, and the square root becomes to the power half. And now we can differentiate this using chain rule. So we have y prime equals plus or minus 16 minus x squared. Take away 1, becomes a minus half, and then multiply by, differentiate what's in the bracket, which is 2x, minus 2x. So y prime becomes, right, so what we can do is, we need a half here as well because we're bringing the half down. When we multiply the minus 2 by the half, the 2 times the half becomes 1, so we can get rid of that half. And then the minus sign, when we multiply by the plus or minus, inverts that sign, so that becomes minus plus x over square root of 16 minus x squared. And that is your answer. Okay, in the previous example when we differentiated y squared plus x squared equals 16, one of the answers we got was minus x over y, and the other answer we got was minus plus x over square root of 16 minus x squared. Wow, you'll be thinking to yourself, they look totally different, but in fact they are the same. If we look at where we use the normal rules of differentiation, we got y equals, so we're going to substitute y into this and see if we can make it look like that. So we had y equals plus or minus 16 minus x squared, and we had y prime equals x over, now we can move this sign down, so we get minus plus 16 minus x squared. To get rid of the minus sign, or to invert the minus sign, we multiply both sides by minus 1, and we get minus x over plus or minus 16 minus x squared. And as you can see that this x over plus or minus is the same as this, so this then is minus x over y. So this answer is the same as that answer. Okay, in this example we're going to have a look at where the product rule is involved in the equation. So we would have x and y together, so 3x y minus x cubed equals y cubed. So differentiating with respect to both sides, we get 3 we're going to have to use the product rule on this part, minus differentiate the x cubed with respect to x, and then differentiating the y cubed with respect to x. So when we differentiate this xy using the product rule, we get 3, let's put it in brackets, product rule. So first differentiate the second, plus the second, differentiate the first, minus, so here we can bracket off that where we're going to apply the product rule, and that equals okay. Now let's distribute the 3 and then use implicit differentiation, we get 3x dy by dx. Here the y becomes 1 and we're left with a dy by dx when we differentiate. So this becomes just dy by dx plus 3y. Here the x becomes 1 and this whole thing disappears. So that's 3x dy by dx plus 3y minus, bring the 3 down, and x squared, so that's minus 3x squared. Then differentiate this y cubed, we get 3y squared dy by dx. Bringing all the dy by dx's to one side, we would get y minus x squared equals and then just tidying that up. And that is your answer. So let's work through another example, slightly more complicated. So x cubed minus 5y power 4 equals 7x squared. So again, differentiate both sides with respect to x. So let's take this a step at a time. So d by dx, x cubed minus d by dx 5y to the power 4 equals d by dx 7x squared minus d by dx 3y plus d by dx 6. Okay, so that's when we're differentiating both sides with respect to x. So let's bring these down. What will we get here when we differentiate that? We'll get 3x squared. When we get this, when we differentiate here, we'll get 20y cubed. Don't forget the dy by dx equals, when we differentiate here, we get 14x. 2 minus 1 becomes 1, so we just get x. Minus 3y becomes 3. Don't forget the dy by dx. And plus 0. Okay. Now what we need to do is bring all the dy by dx terms that we have to one side, and when we do that, try to keep the first term positive, because when we try to solve the equation for y prime, it makes it easier. So we have 3 dy dx minus 20 y cubed dy by dx is 14x minus 3x squared. Here we can factor out the dy by dx. So we have brackets 3 minus 20 y cubed equals 14x minus 3x squared. Keeping the dy by dx onto one side, we have the 14x minus 3x squared all over 3 minus 20 y cubed. And that is your answer. Okay, in this example we're going to use some trig. So we have sine y plus x squared y cubed minus cos x equals 2y. Again, differentiate both sides with respect to x. We have d by dx sine y d by dx x squared y cubed minus d by dx cos x equals d by dx 2y. So we're differentiating both sides with respect to x. Here, use the product rule. And we use the chain rule to find with respect to y. So let's do that then. So here we have d by dy sine y dy by dx plus, this is going to be product rule, x squared d by dy y cubed plus, leave y cubed alone, and then differentiate x squared, that's the product rule, plus sine x or we can just put d by dx cos x, and that will equal d by dy 2y dy by dx. So, as in the first case, let's use a green pen and just do all these individually. That we get cos y dy by dx plus x squared 3y squared dy by dx plus 2x and then we've got the y cubed plus sine x equals 2 dy by dx. So tidying this up, we get 2xy cubed plus sine x equals 2 minus cos y minus 3x squared y squared dy by dx. Therefore dy by dx and all that is divided by 2 minus cos y minus 3x squared y squared, and that is your answer.